Welcome to today's additive printing panel debate. Additive printing has grown very quickly from being a novel method of producing last-minute tooling to something that's been used for producing prototypes and high-precision parts. This panel will debate some of the latest trends. I'm delighted to be joined by three experts from different parts of 3D printing. On my very left, I have Simon Freed from Nano Dimensions. They're making PCBs basically using 3D printing. To my left, I have here Dan Gamoto from Jabil, who are probably one of the most advanced contract manufacturers using 3D printing quite extensively. And to my right, I have Mike O'Reilly from Optomec, who have just come out with a very novel method of 3D printing for advanced packaging applications. So welcome, gentlemen. Okay. So my first question, just to kick things off, in fact, to round this off, I'm going to start with you, Dan. Will 3D printing technologies become a must-have for prototyping and first article? We've got a slide that you provided, which we're going to put up on the screen just now. Maybe you can talk us through it a bit.
Sure. And I love, when I look at this slide, I like the last statement, transforming the way things are made. And historically, Jabil makes things. It's important that any of our customer that comes to us that requires novel equipment sets that we're prepared. And so here we've kind of given a high level view of if you do come to Jabil Additive, these are the types of services that you'll achieve. At Jabil, it's run by my colleague John Dolcinos, and he basically is pulling together a suite of different capabilities all around 3D printing. So right now it's optionality, and it's really more foundational as to, what are the parts that can be produced. We're looking at product design and prototyping services, and really the services are end to end. We can't just say, give us your 3D design. We have to sit down with the people, understand their design, and really work together. So there's much more collaboration in the 3D printing. So this slide kind of speaks to the high level view, but ultimately the last, speed and agility. Being able to give the customer highly customized and highly specialized and personalized product.
Right. Yeah, that's definitely one of the things that I was most impressed with when I visited your Blue Sky Labs. I mean, somebody could walk in with a design for something on a napkin in the morning and walk out with a prototype in the afternoon.
Well, 3D is an enabler. I mean, additive manufacturing enables that vision to come to fruition.
Right. Okay. Simon, you're at another area of 3D printing, and a very complex one, because you're actually building multilayer boards. That's a very complex area, and you've been at it now for a couple of years, and you've now got them in production. Can you talk to us a little bit about that?
Yeah, certainly. So what the focus of Nano Dimension is on additive manufacturing, 3D printing with multiple materials. So it's printing metals and polymers in one and the same parts at the same time. And what that enables you to do is to tackle challenges relating to multi-layered electronics, which is clearly the trend or the norm in PCBs. That every year another layer gets added to what the advanced products need, and that allows you to make a traditional PCB, same feature size, same format, different materials, different process, but ultimately, as Dan was just saying, it allows you that speed, agility, customization, and quick iteration, so you can fail fast or succeed fast, depending on how the development's going. But it allows you to cycle through quickly. The other thing I'd just like to add to that issue of changing how things are made is slight change of the word order, and also changing which things are made, because what we're finding now, and that was certainly a new journey for us, is not just doing PCBs. Not that that's a just, but also looking at how does one really set circuitry free? How can you change the format of your electrical part? How can you give it contours? How can you give it a structural role as well as just an electrical one?
Into like a 3D MID type situation.
But multi-layered 3D MIDs, for example. Right. Or even one can look down into the future. I can see hybrid type manufacturing where you'll have traditional PCBs living comfortably alongside 3D additively produced components or parts that are going to be better at some things, and they're going to be worse at others. So it's about finding the right allocation of that 3D resource.
Right. Mike, you're combining polymers with metals to an extent with your new innovation. Can you tell us a bit about it?
Well, you know, that's another approach, and we have some customers that are trying to print both polymers, metals, dielectrics. But by and large, our technology is really geared towards printing onto existing substrates. So a great example is our technology is being used for high volume production of antennas on smartphones, printing the antennas directly on the case versus traditional seed and plate methodology, specialized polymers, specialized plating baths to develop the antennas. We've kind of shortened that cycle where we can eliminate an entire plating line by directly printing onto the surface of the substrate. Where our technology really comes into play is being able to enable not so much a next generation set of solutions, but being able to miniaturize those solutions. We have the ability to print from 20 microns to millimeters in scale, but as devices get smaller, as packaging gets smaller, as traditional methodologies can't keep up, we fill the gaps in those manufacturing processes. Right. So that's really what we're trying to do. We have many customers that use our systems to print multi-layer printed circuit boards onto existing substrates. So they might have a ceramic substrate and end up printing a 4 to a 7 layer printed circuit board using dielectrics and metals and unique approaches to getting that done. However, by and large, the majority of our customers are using us to fill the gaps in current production methodologies, printing smaller features, etc.
Okay. So Dan, what do you think? Do you think there's a practical and economical addition to any EMS company to have a 3D printer on the factory floor for?
It is. I think if you do not have a additive manufacturing or a strategy for having 3D printing as an option in a supply chain, you're behind the curve. Right. I think that for us, the most important thing is that to go from ideation to product realization, the reality is 3D printing or additive manufacturing will be one of the key elements for that manufacturing. If you don't start now, you're going to be behind the curve. When you think of additive manufacturing, it's not someone who's historically been able to do machining, where the concept of machining is you start out with a block of metal and you shave off that to a certain geometry. This is more of an artist. You're starting out with air and you're able to add it. So the ability to have this design freedom is something that's been unheard of. You have product designers that now will be able to realize these wonderful experiences because now their product is not limited to a certain shape. We feel that by now going in and having a stronger appreciation for the materials, the process, is just half of the equation. The other half is design. Who are the people who are going to design? And actually, quite frankly, those people they're not growing on a tree.
Well, I was going to say,
we have to nurture them.
Right. EMS guys are generally practical guys. They're not necessarily artists.
Right. So that's why we're really trying to spend as much time as possible in the institutes, in the academia, just to try to understand what type of talent do we need to bring on board.
Yeah, exactly. What are you seeing, Simon? I mean, I know you're working at the PCB bare board end, but I mean, you obviously have a wider appreciation of the 3D printing process. Do you think it's going to be a necessary addition to every factory going forward?
Well, certainly in our line of work, we come across guys who are already using additive manufacturing because they're often the same prototyping, NPI, new product groups that are also using or interested in our technology. And these things seem to be evolving in the electronic space in a very similar way to the evolution of the more traditional mechanical 3D printing. And that means here and now, most interest is looking at that early stage ideation, sketch idea and bringing that to life in order to do those quick iterations. Certain areas are moving into manufacturing. I think Optomec is a great example of that, where additive is beginning to step into that role, and we're certainly having those discussions as well. And somewhere around that point, EMS companies, not that I want to put words in your mouth, seem to be looking at things like jigs and test fixtures. How can I perhaps not go all the way to printing the entire final part, but how can I better customize and add flexibility to my production process itself by using additive as part of the production.
Yeah.
And I think down the road, and in some cases, you see it being used in end-use parts as well.
And to that point, jigs and fixtures, engineers see that as a tool in their tool chest. So that has already happened, and we definitely feel that it's going to continue because it is becoming an essential tool for all the engineers. So that's a great proof point to show that the adoption has started, and now everything else is just going to be gravy on this.
Yeah, I think the tooling, it saves time and cost, basically. Rather than having to send something away to get a tool developed, you can literally make it in an hour on your own machine.
And then the ultimate is distributed manufacturing. We see additive manufacturing as the key element for achieving this wonderful vision of distributed manufacturing. Okay. Highly specialized, customized, and personalized.
Yeah. If I can just go to one point on your PCBs for a moment, Simon. I mean, what are the minimum tracks and spaces you can do on a printed circuit board?
So the answer is it depends. The bottom line on the official spec of our currently commercial system is in the region of 4 mil on trace and space, 4.5 thereabouts.
Okay.
But when you're making boards in an additive way or printing them, then the process is so different that if you start digging down into the finer details of what does a conductive profile look like, what's the shape, does it have undercuts? Well, no, it doesn't. Does it have perhaps some tails? Well, yes, it might. So there are certain differences where aspect ratios might behave differently. So if you're looking to see how narrow can a trace get, then the next question would be how high does it have to be, and what's the end application. So it's there's no one size fits all.
No one size fits all. Okay. And how practical is it to print both the substrate and the electronic prototype circuit? I mean,
well, if you're asking the guy using the machine, very practical. If you're asking the guys who had to put the machine together, not so much. So it's on the one hand, it's a multi-material, multi-process, multidisciplinary spaghetti of variables that have to be teased apart and glued together. But essentially, it's certainly doable, and it enables not just that backwards-looking integration with an existing generic need for rapid prototyping of a particular type of circuit, but what we're seeing is when people get it, and I think that was Dan's point, is that there's a lot of unlearning and learning to be done before you start to think in ways that enable fully design for additive. And that's a journey that the mechanical guys have been on for years, and there's work to be done still. The electrical community hasn't really thought about it at all, and so they've got more of a learning curve ahead of them. They can speak to their buddies in the room next door about how this is going to be fundamentally transformed.
So the skills gap is probably one of the biggest barriers at the moment. Yeah.
And to his point, guidelines. There is no mechanical design for additive manufacturing mechanical guideline. There is no design for additive manufacturing electrical design guideline. All these guidelines in the traditional world have been around since 1950. An engineer learns those and applies those during his practice at work. Those don't exist. And for the most part, it is a learning, and there are some companies that have been keeping that close to their chest because they feel that's their value add, that's the intellectual property. But what we're finding is the community is accelerating at speed and growing so quickly, it's becoming much more collaboration. So although these guys, maybe 10 years ago it would have been viewed as competition, today it's much more collaborative because these two are key to anchoring the ecosystem.
Yeah, and that's a great point, Dan. One of the key things we're seeing is, Optimac offers a 5-axis solution. Think of it as a CNC machine for complex geometries. But we're seeing, typically we're taking a substrate and printing onto that existing substrate, an injected molded part. And now we're seeing where customers are saying, well, I've got that part maybe in FeatureCAM or MasterCAM, and I want to now add electronics to it. So we add the additive piece with those same products. However, you can get really funky in what you add onto that part, and now we have to place components onto that part. How do I do that? So that we're just at the tip of the iceberg. As we add functionality to these complex shapes and parts, there's a whole raft of infrastructure that needs to be created to be able to fully functionalize those parts.
Well, I could maybe partly answer that question, and that is Yamaha brought out a pick and place machine that can do assembly of MID components, and they use a robot to basically tilt the substrate onto a planar surface so you can pick and place onto it. And I came across a company a couple of weeks ago in Japan that's actually started a service doing that, using a Yamaha machine, but you can basically send your parts to this company and they'll do the placement side of it.
Interesting.
So it's
yeah, and that's going to be a key driver. If you think about a smartphone and how thin they're getting today, well, if they can take the electronics and embed that into the plastic, versus having a separate printed circuit board or maybe a much smaller printed circuit board, that will give them better advantage into making things smaller, cheaper, lighter.
Nash has a great point, because every additional component you have is another potential failure. What additive manufacturing will allow you to do is to take 10 discrete parts that had to be assembled one by one. Now you have just one part.
Right.
So by taking and reducing the number of part count, and you're basically going to make a much more reliable part, and it'll have greater design.
But better yet on that, Dan, is the discrete parts. The additive manufacturing can actually print those discrete parts.
Exactly.
In many cases, people are using our technology to print pull-ups and pull-down resistor, printing the material directly onto maybe the top of a paralene where they've, it's been a low-volume DoD application, and they hooked up the circuit wrong, so they need to cut through the paralene and bring a wire to the other side and put a pull-up or a pull-down resistor in the middle. Instead, they cut the paralene, print the connection from one side to the other, print the resistor, tie them together, and it's all done.
Right.
So as another example of what if we could print all those discretes directly, save lots of space.
Right. Okay. Well, guys, we're running very tight on time today, so I'm going to come to my last question, which is, are there any real limitations where it's difficult to use 3D printing? What are the limitations? Let's start with Simon.
Well, I think 3D printing, regardless of whether it's in the electronic space or in the mechanical space, at the end of the day, it falls down to process and materials. And you see this in the metal printing space. How much testing do you have to do on a part that's going to go into an aircraft? How much porosity can you accept in your part? What is the strength? It means that there are certain things around testing that have to be done differently. There are going to be material sets that are possible. Different printing technologies can use different types of material sets. So I think depending on the challenge, you'll need a different type of additive. You'll certainly need a different way of doing quality assurance, for example. In some ways, you can do it in real time with additive manufacturing, which is not so easy with some of the other technologies. So there are pros and cons. There are certainly some things that additive won't be able to do, and certainly won't be able to do at very, very high volume anytime soon.
Right.
But we're beginning to see that the roadmap is really going to start taking bigger and bigger bites, particularly where things are customized, complex, or distributed in some geographical way.
Yeah, and taking some of the software developments that have come in recently, we might be able to use some digital twins to sort of look ahead. What do you think the limitations are there?
I concur with everything he said. I think it's really establishing a portfolio of documentation, design guidelines, quality assurance processes. I think that right now there's a slight resistance for adoption simply because they don't know the benefits, and they need to first see how it stacks up, how traditional stacks up with 3D or additive manufacturing. I think once people see a one-to-one comparison, once they understand that the supply chain has been fully vetted and that the materials, to your point, materials, design, and processes have been certified to be on par with what exists or even better, I think it's going to be the tipping point. But right now, I think people are a little bit, you have your first adopters, and I think they're very strong, and I think those are the ones that are going to help you build this portfolio of collateral that basically is going to push us over the tipping point.
Right. There you go. All right. Last word to you, Mike.
I agree with both my colleagues here. I think our biggest challenge, well, first of all, Dan is talking about standards, and I think that's still difficult. This is still an emerging technology. There's still a lot of learning that has to go on. So building standards could be restrictive. And I'm not sure we want to restrict the technology yet. I think building standards is a good thing, but let's not restrict it. But I would say our biggest challenge, at least from an Optimec perspective, is materials. This clientele here at this trade show is used to a set of materials. They can get it from many different vendors. But the processes we use, the way that we deposit materials, etc., require a new class of materials, and trying to get vendors to develop those materials for you, especially for, the volumes are low, they're just, we'll wait till you hit the mainstream. Well, that's inhibiting us from really reaching our full potential in the near term. So.
Right. So basically trying to get the message across and improve the technology.
That's exactly right.
Yeah, very different. Fantastic debate, guys. Thank you very much for joining us. To my left, we have Simon Freed from Nano Dimension, Dan Gamoto from Jabil, and of course Mike O'Reilly from Optimec. Gentlemen, thank you very much, and thank you for joining us.